So before the interruption, in our class then, I was trying to talk about a hybrid topology. There have been power failure, is it power failure? Network failure, yes. Hybrid means a combination of two or more of the topology. You can actually bring them together to form a hybrid. And then we have different categories of network. We have the local area network, we have the wireless local area network, metropolitan area network, and wide area network. I think it defines the kind of size, the size of the network. The local area network, LAN, is the smallest, very small, and it covers connection of computers within a small building, a big building like a LAN headquarters, or some other buildings that are close to it. And in most cases, it makes use of wires. By the time you now have wireless transmitters coming together to connect these computers, you now have wireless local area network. It's still a form of local area network. The metropolitan area network is bigger. It covers a metropolis or a town, a big town, a city, one or more states put together. I think a very big network. The computers there, when they are connected together, you now have what you call a metropolitan area network. Then the biggest of them all is the wide area network, which can span connection of computers between two countries, big geographical regions and so on. Can be two continents and so on. And today in the world, the biggest wide area network we have around is the internet. The internet happens to be the biggest wide area network we are having. Then for the internet, one way or the other, that connected so many computers around the world together is the biggest network we have in the world today, the biggest wireless wide area network. It has changed many aspects of our daily lives. It has affected the way we do business as well as the way we spend our leisure time. The internet is a communication system that has brought a wealth of information to our fingertips and organized it for our use. And the internet, as at when it came about, it came around in the 1960s, in the mid-1960s, when the United States Defense Department set up a body called the Advanced Research Project Agency, ARPA, with the task of joining the existing computers together so that they can be communicating among themselves and produce a big wide area network. At the end of that particular decade, 1969 to 70, they succeeded in connecting the computers, and the result was a network. The resulting network was now called ARPANET, Advanced Research Project Agency Network. That was it. And the ARPANET started growing, became a military network, and different research agencies started using it until 1990, when a researcher called Tim Berners-Lee, working with CERN, European Center for Nuclear Research, now came and said, this particular network called ARPANET can actually be opened up to the public and made more or less a civilian kind of network for public use. And he now developed some rules, which he called protocols, put them together, and these protocols could help moderate how messages are sent, how messages are formatted and the other. He actually developed web pages and developed the World Wide Web. So in 1991, the network he now helped in modernizing, opened up to the public, and was now named the Internet. Internet being a short form for International Network. So this Internet makes use of protocols and standards. Protocol is synonymous with rules. Standards are agreed upon with what actually we all agree. And so the Internet on its own does not have a body that controls it or a headquarter, but it has several bodies that they agree, people who are using it agree together, should enforce standards. So you have organizations and some other Internet standards. So for the protocols, they can help you format your data, give you the syntax of the data, the semantics, the meaning of each part of the data, timing, when data should be sent and how fast. Standards are de facto, by fact, not approved as a standard. De jure, by law, it is approved by governments, organizations that are using it. And we have some organizations that are actually contributing to the standard of the internet. We have the International Standards Organization, International Organization for Standardization. We have the International Telecommunications Union standards, the American National Standards Institute, ANSI, Institute of Electrical and Electronic Engineers, IEEE, and Electronic Industries Association, EIA. So I think this other one will talk about network model. It's still part of this class. The layered architecture that describes the way tasks and messages are broken down. So for the architecture, we have the network model, which is a layered architecture. In this model, tasks are broken into small tasks, implemented separately in layers in stack. And then there's a function that is needed in both systems, like that, the layers, and then the stack. And then you have the protocol set of rules that govern data communication, which also represents an agreement between the communicating devices. For example, you want to send a letter. The task involved in sending a letter. You have the sender, the receiver, and the carrier hierarchy services. And then the sender may compose the messages broken down into components, which will now be defined by the network, interpreted by the network. Then at the end of the day, these components will be formatted in a way that they can pass through the medium, get to its destination, formatted back again, until you now get your original message back. The OSI model is the most popular network model, which was established in 1947 by the ISO, International Standards Organization. And the ISO is a multinational body dedicated to worldwide agreement on international standards. And the ISO model is the Open Systems Interconnection model. That is the OSI model is the Open Systems Interconnection model, which is the standard that covers all aspects of network communication. It was first introduced in the late 1970s to the public. So we look at the architecture. There are 7 layers of the OSI model. You have the application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. That is the layered architecture. Application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer, as the case may be. These 7 layers make up the layered architecture, which is a layer model. And each layer performs a subset of the required communication function and relies on the next lower layer to perform more primitive function. Each layer provides services to the next higher layer. So the layer below it services it, and then it services the layer above it. And changes in one layer should not require changes in another layer. They're supposed to be a bit independent. And the processes on each machine at a given layer are called peer-to-peer processes. Peer-to-peer processes here, it tells you that the passing of the data and network information down through the layers of the sending device and back up through the layers of the receiving device is made possible by interface between each of adjacent layers. So the communication must move downward through the layers on the sending device, over the communication channel, and upward to the receiving device this way. It moves downward like this. Okay, it may not be visible here. It moves downward this way through the sender, When it gets to the end, it comes back. As it gets to the receiver layer, it start moving upwards. So that is how it is formatted or organized. The interaction between layers in the OSI model, this particular diagram explains it. We have two computers or two devices that are communicating, and then they are moving from the application, presentation, system, transport, network, data link, and physical layer up to we get to the other computer. From physical, it goes to data link, goes to network, transport, it now goes to session, presentation, and finally application that will view it at the end of the day. Exchange between the OSI model. You look at this diagram closely. Maybe when you expand it, you look at it. I will send the slide to you later. So let's look at each of these layers one by one. Physical layer is responsible for movement of individual bits from one node to the other. Function, it helps to represent bits, data rate, synchronization of bits, physical topology, it helps to identify it, transmission mode, simplex, half duplex, or full duplex is taken care of by the physical layer. And the physical characteristics of interfaces and media are determined by the physical layer. So from data link layer, you get to the physical layer from the sending device. And then here, the data is now represented in binary form. That is the part the computer will understand. And now sent to the transmission medium. If you get to its destination, it goes through the same physical layer at the bottom in the receiving device. And from there, it moves up to the data link layer. The data link layer is responsible for moving frames from one node to the other. The function is framing, physical addressing, flow control, error control, and access control. So from the sending device, from the network layer, you get to the data link layer. From data link layer, the message is now put in the form that the physical layer will now pick. When it gets to the receiving the device, physical layer will now present it to the data link layer, which after doing the necessary conversion, is ended everything to the network layer. Then there's also what you call hop-to-hop delivery. From one particular device to another is moving step by step to go and deliver. So this one is an example. Data link level. The frame contains physical addresses in the header, and these are the only addresses needed. The rest of the header contains other information needed at this level. So the next one is the network layer, which is responsible for the delivery of individual packets from the source to the destination. Source to destination delivery is one. Responsible for the delivery of packets from the original source to the final destination. Functions of the network layer, logical addressing and routing. So this is an example of the network layer. Oh, sorry. Then the next one is transport layer, which is responsible for the delivery of a message from one process to another. A process can be a task that is running inside the computer. So process to process delivery within is done by the transport layer. And the function is port addressing. The port contains where you can now connect external devices and they start communicating with the computer. Segmentation and reassembly, connection control, flow control, and error control. This is transport layer, segmentation and reassembly. What do you mean by segmentation? You break the messages into different components. Reassembly, you now bring them back together again at the end of the day. So from the session layer, messages are broken down, and then the transport layer now send it into segments, send them to the network layer. When they get to the destination computer, by the time it is moving from data link and it gets to network layer, the messages are now sent, because they are still broken down, sent back to the transport layer. Transport layer will now arrange them together and send it back to the session layer, which happens to be the next. The session layer is responsible for dialogue control and synchronization. What does it do? It establishes, it maintains, and synchronizes the interaction between communicating systems. And the function of the session layer is to control dialogue and maybe carry out what you call synchronization through the creation of checkpoints. This is the session layer. For the presentation layer, it synchronizes and then sends it to the transport layer, which now breaks it down into different segments and sends it down. And then when it's coming back from transport layer for destination devices, it sends it to this particular session layer, which after doing its job, send it to the presentation layer. Presentation layer is responsible for translation, compression, and encryption. When you say translation, changing it into a form that the device can understand. Compression, the message may be big. It now has to reduce the space it occupies by reducing the message size, but still maintaining whatever is the message to still be intact. Encryption means to change the original message into meaningless forms that are now protected. And then with a key, when it gets to its destination, you can actually decrypt. Presentation layer is concerned with the syntax and semantics of information exchange between the two systems. When you say syntax and semantics, it means the way you arrange whatever messages you want to send. Semantics, the meaning that is ascribed to each of these messages. So the functions of the presentation layer is supposed to present your message in a form that the system will understand, translated EBCDIC coded text file to ASCII coded file. What you mean by translation is that your message may be presented in normal English syntax. Your presentation layer will now decode it into binary that the machine language of the computer can understand. They can now encrypt and decrypt your message and actually carry out compression. From presentation layer, you go to the final one, which is at the top, application layer. That is where your message is actually created. And then even when it gets to destination computer, application layer also receives your message so that you can, in the right format in which it was sent. So application layer is responsible for providing services to the user. And that is the interface that the user interacts with. So network virtual, it allows remote login, file transfer and access, mail services, directory services, and accessing the World Wide Web. When the messages are presented in human form, they are now translated into a form that the computer can understand. And when it gets to its destination, they are presented in a form that the computer can understand. And then they are now translated back into human form so that the person can actually read it. So the 7 layers are application, allow access to network resources. Presentation, translate, encrypt, and compress data. Session, establish, manage, and terminate sessions. Transport, provide reliable process to process message delivery and error recovery. Network, move packets from source to destination to provide internetworking. Then data link, organized bits into frames to provide hub-to-hub delivery. And finally, physical, transmit bits over a medium to provide mechanical and electrical specification. So these are the summary of the layers, the OSI layer, again, from application down to physical layer. I think that is where we will end the class for today. I'm so sorry about the network problem, but that is not the only thing I'm sorry about. I'm also sorry that we have not started this class for a long time. And I've been pleading with the class rep, but she seems to be telling me that people don't have any free chance. I wanted you guys to create an additional 1 hour a week. We can do it for like 3 weeks so that we can catch up. In addition to this one, I was pleading, but she said there's no hope. about that so that we can catch up. We are behind. This is supposed to be our 4th week. We're now treating this as our 1st week, and that is not proper. So please, is there any way I can get some concession from the class?
Okay, sir. Hi guys. Everyone is on the call. So I know I've put it on the group, but the participation has been very low, like agreement. And so we have classes every day, some 5 to 6, some 6 to 7. So if we choose any other day, then we can add it to that one. So let's say our views here that Prof has raised it again. Saturday, our class, we've never had it. It's one management course like that. I hope everyone can hear me.
Which time on Saturday?
I don't know.
Yeah,
let's decide. Let's say our opinion.
Okay. So I'll say, since those days I'll have only one course, we can share that day with him. Like those days I'll have only one course that day.
When do you normally have classes on Wednesday? On Monday, sorry.
I said Monday.
No, Monday. When do you normally have classes? How many classes?
It's today now, just this one that we're having now.
And if I need to adjust this one, maybe I would have started an hour earlier. So that
okay, like 5?
Yes.
Okay. What else that? Is it okay with everyone?
Start an hour earlier so that I'll cover 2 hours.
Yeah, it's fine. We can make it 2 hours.
I will not stay till 7. I'll just cover 50 minutes per class so that those of you that are still moving can move to your houses.
It's fine, sir.
It's okay by me.
What will happen? The Zoom recording will be sent to you later.
Okay.
And then the slide, I will go to your course page with effect from maybe tomorrow or later this night. Edit it and put your slides there.
Okay.
And if you have any questions, my WhatsApp number is with the class rep. She can give it to you guys to always ask questions. So I'll carry everybody along and see how much we can cover between now and when we are evaluating the exams. Minimally, we are supposed to have 8 classes. So that's why I'm bothered, so that we meet up no matter what. But I know we can meet up. Even if it takes us, when it gets close to exam and most people have completed their classes, we can just be using their period within the week and cover up. I know we'll meet up. But if you have any aspect of the course you don't understand, maybe as I'm teaching, please, you have every right to ask questions. Don't assume. And like for today's class now, I did not use your material. But for your subsequent classes, I will use your material because that is where the bulk of your questions will come out so that it flows, because I don't want to copy from the material, but I'll try and produce a slide from the material so that you can understand it better. So if you have any question, even outside the class, you can always ask a question, please. I'm very, very open to questions. And then the lecture delivery mode, I may be very fast. You can slow me down. I may be very slow. You can hasten me up. Because the Monday now, why I was scared, I didn't even know it was Monday. My classes end by 5 o'clock. Then if it's a 3-hour class, end by 5. If I now start taking you from 5 to 7, that makes it a 5-hour class, after which I go and rest. So let's see how it goes. By next Monday, I think I'll be a bit empowered. We'll still have an elongated class. We'll start by 5 or 10 minutes after 5 and teach till 7. And that will be okay. The link has been sent to you. That becomes a permanent link we'll be using till the end of the class. So any question, please?
I don't have no questions for now.
Chinyere, any question?
Yes, sir, not for now.
Okay, you are planning, not for now. It's okay. So I'll get back to you guys. So If we don't have any other class, then on Monday we'll meet again. But on Monday, be sure that we are going to have 2 classes.
Okay, that's fine, sir.
Yeah, take good care of yourself.
Okay, sir. Thank you.
Have a blessed
okay.
day ahead of you.
Yeah, you too, sir. Thank you.
Okay.